folks, let's keep going now that you've talked about the opener and kind of saw the difference of implicit differentiation. We're just going to go through class examples today with this hope of understanding section 4.2. So we have example 2, and we're asked to find the derivative. So we're given, we'll write it as x squared plus y squared equals 16. And again, we don't want to replace everything we've been doing. We don't want to assume I'm always using implicit differentiation, right? I want to look at this example and turn and tell your partner, why are we using implicit differentiation? What is it about this problem that screams implicit differentiation? Right, since y is not expressed solely in terms of x. So I'm going to solve it explicitly first and then compare it to the implicit approach. So again, explicitly is what we would have done solving for y. So I'm going to solve for y. I get y squared is equal to 16 minus x squared. I take the square root. I get y is equal to the square root of 16 minus x squared. I'm going to rewrite that using everything we've talked about in chapter 3.1 to 4.1. I'm going to rewrite it using exponent rules instead of a radical. So when I go to find derivative, I'm going to have dy dx. Using power rule, I have 1/2 times the quantity, 16 minus x squared, to the negative 1/2. I have to apply chain rule. Derivative of my inside function is not 1, so I'm going to multiply that link by link chain rule and times it by a negative 2x. And then I'm going to simplify. I have dy dx is equal to negative 2x times 1/2 is negative x, all over the square root of 16 minus x squared. So again, that's what we would have had to do up until yesterday. To find the derivative, we would have had to solve explicitly. Solve for y, and then ultimately take the derivative after we've solved for y or got y expressed in terms of x. Let's compare that now to our new approach today, implicit differentiation. So we're going to take x squared plus y squared equal to 16. Again, we want to remind ourselves that when we're thinking implicitly, we're thinking ultimately y is a function of x. Keep saying that to yourself. Y is a function of x. So I'm going to work through, I see a power rule. So I have 2x plus 2y, derivative of a constant, goes to 0. Right? When I look at that 10-second checks, often students will use their algebra brain and get used to just bringing down the 16, right? Carrying it down. When we want to think opposite thoughts here a little bit and thinking the derivative of a constant goes to 0. But if I pause right now, and if you paid attention to our opener, right, our first example, when I look at this problem, I'm never going to get to where I need to go. Remember, the goal is to find the derivative. At this point, I have no derivative notation, and this is what I was explaining in the last example. So we have to think about y is a function of x, right? So here we're thinking 2 times x, but the derivative of x goes to 1. Here, though, we have to picture that chain rule. We have 2 times the quantity of y times the derivative of y, but y is a function of x, so we can't assume it goes to 1. Again, if I don't get dy dx in that first step of my calculus differentiation, it's never going to get to what I'm solving for. It'd be like looking for x and never having x on your paper. So now I'm going to solve for dy dx. Subtracting over our 2x, dividing by 2y, I get dy dx is equal to negative 2x divided by 2y, or simply dy dx is equal to negative x over y. All right, and again, we can check that this works because we've already solved for y, so I can check that both my implicit and explicit are equivalent statements. So I get dy dx is equal to negative x over y. If I substitute what we found earlier, we found y to be square root of 16 minus x squared. If I substitute that in, we get that full check of our implicit versus explicit. All right, I'm going to write up the next example, and what I want you to do is pause the video and try it on your own. Right? Try solving it both explicitly and implicitly, if possible. So you're going to try 3 on your own, and then you're going to stop this video and start up with the next one. So again, you're going to try to solve it implicitly. And then explicitly as well to compare them. So you're going to stop the video, try solving it explicitly, then implicitly to see if you end up where we need to. Then you'll go to the next video. See you there.